So dear students, like today onwards, we will be revising topic in a crash course fashion where we won't be doing the entire things, but we will be doing the major concepts. We will be revising the major concepts and we'll do questions which have been there in previous years of JEE and JEE Mains Advanced. So that will be quite a refreshing thing for you. You will be going through the concepts again. Some of, I would say not all the concepts because there are very few classes. Like in the next two classes and today and next class, we will be covering sequence and progression. And in the next two classes after that, we will be covering binomial theorem, their examples, their properties, questions over them, which have been there in JEE Main, JEE Advanced. So we will be doing all that. All right. So today I'm going to start with sequence and progression. All right. So the first thing that comes into picture is arithmetic progression. Arithmetic progression. So we all are already aware of this, what it is. So I'll be covering very small things, but yes, worth considering about arithmetic progression so that we cover the important topics and then simultaneously we will do questions over it. All right. So first of all, we all are aware of what is arithmetic progression. Quickly, I will do sequence of the type of A plus D, A plus 2D, A plus 3D, and so on. This is what we call an AP. Its nth term is, you all know, A plus n minus 1 into D. Agreed? Sum of its nth term is n by 2, 2A plus n minus 1 into D. And the sum of n term can also be written as n by 2. It is first term plus nth term. So sum of n terms is also n by 2 first plus last. Now few small things about it. Sum of n terms of AP, sum of n terms of an AP is a quadratic in n. Is a quadratic in n without any absolute term. Without any absolute term. Like if you see sum as Pn square plus Qn, this is definitely going to be the sum of n terms of AP. But if you see Sn as Pn square plus Qn plus R, this is not the sum of n terms of an AP. Understood? Now, few small things about sigma notation. You all are aware of sigma R. R varying 1 to n is what? Basically 1 plus 2 plus 3 up to n. So it comes out to be n into n plus 1 upon 2. Am I clear? Now, sigma R varying from 1 to n R square. So that is 1 square plus 2 square plus 3 square up to n square. This formula is n plus 1 to n plus 1 upon 6. Correct? Now sigma R varying from 1 to n R cube. So that is 1 cube plus 2 cube plus 3 cube up to n cube. And this formula is n into n plus 1 upon 2. Now, one or two more things to remember. Sum of first n even natural numbers. That is what? 2 plus 4 plus 6 plus 8 up to 2n. So this is equals to n into n plus 1. Got it? And sum of first n odd natural numbers is like 1 plus 3 plus 5 plus 7 up to 2n minus 1, and this is equals to n square. Very important result. Very important. Got it? And last, very small thing, 1 plus 2 plus 3 up to 100. This is equals to 5050. I think this much of results you should remember and you can remember. Got it? Now, let's do one or two questions over it. Okay, one or two more things. Sometimes if you have to take three terms in AP, you have to take three terms in AP, then take them like A minus D, A plus D. If you have to take four terms in AP, that should be A minus 3D, A minus D, A plus D, and A plus 3D. If you have to take five terms in AP, that should be A minus 2D, A minus D, A plus D, and A plus 2D. Got it? So this is how we take terms. But the taking terms like this is only worth considering if in the problem they are talking about the sum of terms. If they are not talking about sum of terms, this is not so worthy. Then you can directly take three terms as A plus D, A plus 2D. That will also work the same manner. Got it? Have a look. Now, try this question. Try this quickly. Let 3, 7, 11, 15 up to 403, 2, 5, 8, 11 up to 404 be two arithmetic progressions. Then the sum of the common terms in them is equal to common terms. So there are two duties now. First of all, identify the common terms, make their series, find the number of terms in that series which is having common terms of both of them. Then find the sum of those terms. Yes, please. Yes, be quick. Now see, let me do it. Now there are two series. One is 3, 7, 11, 15, and so on up to 403. If you realize their common difference is 4. Yes or no? Another series is 2, 5, 8, 11, 14, and so on, 404. Got it? Now, just a moment. Now, this common difference is 3 here. You realize that? So, the first common term in both the series is 11. Again, for the next common term, they will again clock at a gap of 12. One series is having common difference 4, other is having common difference 3. So, series with their common difference, with their common terms, I should say, series with their common terms will have common difference as LCM of 4 and 3, that is 12. So now if I write the series with their common terms, it will be 11, then 23, then 35, and so. Got it? Now see, the common term can be 403 maximum. So if I talk about the nth term of this series, it will be 11 plus n minus 1 into 12. It should be less than or equal to 403. So n minus 1 into 12 less than equals to 394. So n minus 1 less than equals to 394 upon 12. So n is less than or equals to 394 by 12 plus 1. That means n is less than or equals to 32 point something. Sorry, 33 point something it will be. N is less than or equals to 33 point something. So if it is less than or equals to 33 point something, that means the last common term will be 33rd term. Agreed? The last common term will be 33rd term. So sum of these 33 terms is 33 by 2. First term is 11. That is 2a. So 22 plus n minus 1 into d is 12. So it is 33 into 11 plus 33 into 32 into 6. So now if you simplify it, you will get 6699. Understood? Anybody having any doubt? Just put your doubt in the chat box or just switch on your mic and speak up. Anybody? Have a look of it quickly. Got it? Now, let's jump to geometric progression. The standard appearance of GP is we all know A, AR, AR square, AR cube, and so on. So nth term of this GP is AR to the power n minus 1. And sum of n terms is A R to the power n minus 1 upon R minus 1. If it is an infinite GP and common ratio lies between minus 1 to 1. This is necessary to find sum of infinite terms. Then sum up to infinite terms is A upon 1 minus R. Then sum up to infinite terms will be A upon 1 minus R. This can also be remembered as 1 minus R to the power n upon 1 minus R. And it does not make any difference either you use first one or second one. They are derived from each other, taking minus common from numerator and denominator. Now, if we multiply or divide geometric progression by a non-zero constant, it still remains a GP. It still remains a GP. Now, sometimes three terms in GP. So it will be A by R, AR. Four terms in GP, A by R cube, A upon R, AR, and AR cube. Five terms in GP, A by R square, A by R, AR, and AR square. Understood? So sometime if you have to assume terms in GP, then you can assume like this. Have a look quickly. Got it? Now, 3ABC being AP, C. The question is 3A, B, C, they all are in AP. And 3, A minus 1, B plus 1, C plus 9, they are in GP. The question is arithmetic mean of A, B, and C. So they are asking you for A plus B plus C upon 3. What it is? Yes, do it quick. Yes, everybody, quick, quick. Now see, three terms they're talking about. Let us say this is 3 only. Let us take A as 3 plus D, B as 3 plus 2D, and C as 3 plus 3D. Got it? So these are, I assume, three terms in AP. Now here, what it will be? This 3 will remain 3. A minus 1 will be 2 plus D. B plus 1 will be 4 plus 2D. And C plus 9 will be 12 plus 3D. Now they are in GP. So if they are in GP, that means 2 plus D upon 3 is equals to 4 plus 2D upon 2 plus D. This is also equals to 12 plus 3D upon 4 plus 2D. Now see, this one equation is having one parameter only, that is D. So first of all, I'll take care of this. Got it? So it is 2 plus D upon 3 is, if I take 2 common from the numerator, it is 2 plus D upon 2 plus D. This is cancelled. That means 2 plus D upon 3 is equals to 2. That means D equals to 3 to the 6 minus 2, 4. Now, but doing this is not sufficient. You just verify also. So if you take D as 4, what is this ratio? 6 by 3, 2. What is this? This will come to. What is this ratio? This is 24 upon 12, which is also 2. So everything is fine. Your D is only 4. Agreed? So if D is 4, your terms became, this is 3, this is 7, 4 to the 8 and 3, 11, 4 3 ja 12 plus 3, 15. So these are your 5 terms. 4 terms. Am I correct? Now what they are asking for arithmetic mean of ABC. So arithmetic mean is A plus B plus C upon 3. That is 7 plus 11 plus 15 upon 3. So that is 33 by 3. Your answer is 11. Got it? Have a look. Very good question. Then this came in JEE Main last year only. Am I clear? Now, let's go with next question. I give you a couple of minutes to think over it. Then we'll run a poll. Let us see how many of you make it correct. Quickly, have an attempt for 1 minute, then I'll run the poll. Yes, if you got the correct answer, mark your answer in this poll. Be quick. All right. Nobody. Nobody means nobody. Very bad. I expected at least few of you to do it. Now see, if in a GP of 64 terms, they are saying 64 terms, the sum of all the terms, so let us assume GP is AR, AR square, AR cube, and so on. So sum of all the terms, that means A plus AR plus AR square up to total 64 terms is 7 times sum of odd terms of the GP. Odd term, like they want to say terms at the odd places. That means A plus AR square plus AR to the power 4. Now it will be having 32 terms. So this is what A R to the power 64 minus 1 upon R minus 1 is 7 times A. Now common ratio is R square having 32 terms minus 1 upon R square minus 1. Understood? Now see this A cancel, R to the power 64 minus 1 cancel. So you got R square minus 1 upon R minus 1 as 7. That means R minus 1 into R plus 1 upon R minus 1 as 7. This is also cancelled. So R plus 1 is 7. That means R equals to 6. Understood? Very simple, easy question. Now, harmonic progression. There's nothing which is particularly different about harmonic progression. We are not going to remember any formula for it. The only thing is if A, B, C, D, these terms are in harmonic progression, that means it's reciprocal 1 by A, 1 by B, 1 by C, 1 by D, and so on. They will be in arithmetic progression. That's it. So whenever we will be having any question on harmonic progression, what are we going to do? We will just reverse the terms and take reciprocal of every term and say that now this is an AP. So we will do everything about an AP. Still, there is no formula to find the sum of n terms of HP. There is no formula for this to find the sum of n terms of an HP. All right. So that's it. Whenever we are having any question, we will just reverse the term and say that it is in AP. Now come to AGP. AGP is what? Arithmetic geometric progression. Arithmetic geometric progression. Like, let us take a series S as A plus D plus A plus 2D and so on A plus
unknown caller
n minus 1 into D. Now you must be thinking this is an AP. Now I multiply it by R square 1 plus R to the power n minus 1. Now see, if you realize there is an AP going A plus D, A plus 2D, A plus n minus 1D. And then there is a GP going R square, R cube, then R to the power n minus 1. So there is a AP going, there is a GP going simultaneously. So this is what we have called arithmetic geometric progression. Now, how do we find the sum of this series? Do one thing, multiply this series by their common ratio of the GP. Common ratio is R and write the series again by pushing one term. So here it will be AR. Here it will be A plus D R square. Here it will be A plus n minus 2D R to the power n minus 1. And A plus n minus 1 into D into R to the power n. Understood? Now you subtract both the series. Subtract both of them. So this is S times 1 minus R. This is A. Now next term onwards, if you take their difference, it is going to be dr. Now their difference, it is going to be dr square. And so on up to this point, difference will be there and it will be dr to the power n minus 1. And then the last term will be a plus n minus 1 into d into r to the power n. Got it? Now if I simplify it a bit, 1 minus r is a plus. Now this is what? This is a GP of n minus 1 terms. So it is dr r to the power n minus 1 minus 1. Let me write it like this. 1 minus r to the power n minus 1 upon 1 minus r minus a plus n minus 1 into d into r to the power n. Got it? So S comes what? A upon 1 minus r dr 1 minus r to the power n minus 1 upon 1 minus r whole square a plus n minus 1 into d into r to the power n upon 1 minus. So what is there to focus is not the formula. You don't have to remember this formula. Even you cannot remember this formula. Getting my point? So what is there is the strategy. So whenever we will be having any question over the AGP, we will remember the strategy, how we are going to implement it. Understood? Have a look quickly. AGP and AP and AGP are going hand in hand simultaneously. Now, let's do a question on AGP. Find P if, now they are saying sum of this series is 8. Then they are asking you to find the value of P. Now let's take it like this. First of all, let us take series as S. So it is 3, then 3 plus P into 1 by 4, then 3 plus 2P into 1 by 4 square, 3 plus 3P into 1 by 4 cube, and so this is going till infinite. Multiply this series by 4 by 1 by 4, which is the common ratio of GP. So it will be 3 by 4, 3 plus P into 1 by 4 square, 3 plus 2P into 1 upon 4 cube, and so on. Now if you subtract both of them, this will be 3S by 4 is 3 plus P by 4, P by 4 square, P upon 4 cube plus and so on. Got it? Now S is given to me as 8. So put it 8, 8 3 is 24 by 4. 6 minus 3 is going to be, now see, this is infinite GP. So it is A upon 1 minus R. Got it? So 6 minus 3, 3 equals to P upon 3. So your P goes 9. Simple question involving a GP and a GP of infinite terms. Have a look quickly. Got it? Now let's start with AM, GM, and HM inequality. First of all, what is AM, GM, HM, and what is the inequality involved with them? All right, let N positive, this positive is very necessary. You won't be able to apply the AM, GM inequality if you do not see this word positive. If N positive numbers are such that A1, A2, A3, A4 up to AN. Mark this word positive, it is extremely necessary. And their arithmetic mean is A1 plus A2 plus A3 up to AN whole divided by N. Their geometric mean is A1, A2, A3 up to AN whole to the power 1 by N, and their harmonic mean is N upon 1 by A1 plus 1 by A2 plus 1 by A3 up to 1 upon AN. Got it? Now I'm not going into the proof of AMJM inequality, but the inequality is arithmetic mean more than or equal to geometric mean, which in turn is more than or equal to harmonic mean. Got it? And equality holds when all the terms are equal. All the terms means the terms on which AMGM inequality is applied, they are equal. Got it? Unknown caller. Now, let's do first of all a simple question. Find the minimum value of A plus B plus C plus D into 1 by A plus 1 by B plus 1 by C plus 1 by D. Given A, B, C, D all are greater than 0. So whenever in any question they are talking about that A, B, C, D, they are positive, that means and they are talking about the minimum value of something. So the first thing that should strike to your mind is that this question might be a question of AMGM inequality. And mark my words, in 90% cases, it will be. It will be a question of AMGM inequality. All right. Now, if I talk about AM more than equal to GM, so A plus B plus C plus D by 4 more than equals to ABCD raised to the power 1 by 4. Now, if I talk about 1 by A, 1 by B, 1 by C, 1 by D. So their AM is 1 by A plus 1 by B plus 1 by C plus 1 by D by 4 more than equals to their product. That is 1 upon ABCD whole to the power 1 by 4. Got it? And now if I multiply both of them, you get A plus B plus C plus D into 1 by A plus 1 by B plus 1 by C plus 1 by D whole divided by 16 more than or equals to 1. So the minimum value of your expression is going to be 16. This question can also be done in a little bit of easier way if I directly use AM more than equals to HM. So for four positive numbers A, B, C, D, what is arithmetic mean? A plus B plus C plus D by 4 is more than equals to. What is their harmonic mean is 4 upon 1 by A plus 1 by B plus 1 by C plus 1 by D. Understood? So in this case, it will be A plus B plus C plus D into 1 by A plus 1 by B plus 1 by C plus 1 by D more than or equal to 60. Directly we can do if we are aware of AM-HM inequality. Understood? Now in our next class, we will do one more question on AMGM inequality. Then we'll talk about some very amazing miscellaneous kind of series questions. Make sure you do not miss the next lecture. It is going to be extremely important, full of knowledge and things which are still beyond your control, and we will do them thoroughly. I'll try to cover as many miscellaneous series as I can, and we'll also let you know the different methods to simplify them. All right. So till then, I will end this class right here. And just a moment before ending this class, I would like to ask you about the feedback about